This warm-up asks us to multiply. So I have 3.4 times 5.1. 1 times 4 is 4. 1 times 3 is 3. Then we use that 0 as a spacer. 5 times 4 is 20. 5 times 3 is 15. Plus 2 more makes 17. And then I can add them up. That would be 4, 3, 7, and 1. I have 2 decimal spots in the question, so I need 2 in the answer as well. So this is 17.34. Question 1 asks you to measure the distance around the circle in centimeters. And you're going to be provided with a regular ruler. And so you can start by creating marks every 1 centimeter. And then turn your ruler and put another mark at 1 centimeter and try and measure it that way. If you have one of those flexible rulers, you might be able to try and curve it around the circle. Do you think that type of measurement is going to be very precise? What other strategy might we use that would help us get a better answer or a better approximation? So you decide in centimeters how big around the circle you think this is based on the measurement you were able to gather. Another way that might be helpful is if we used a string and we lay it around the outside of the circle, and then we measure it against a straight ruler to see how long that string is. Then it says measure the distance around the circle from problem 1 again. So now using the string, you should end up with an estimation that's about 35 centimeters. And it's okay if it's not perfect because we're using a strategy that isn't ideal for this situation. For example, it might be difficult to hold that string in place around the edge of the circle if you're working by yourself. It says use the table to record your data. We are going to measure a few items that are circles in real life. So some 3D objects. In a classroom, you might have like a hula hoop or, I don't know, a jar that you have pencils that sit in. I am working from home, and so I have a glass. I have a can of pineapple. I have a small bucket, and then I also have a mixing bowl. So all of them have circle tops, and I'm going to measure the diameter, which is the distance across, and then I'm also going to measure the distance around the circle. And I'm using a flexible measuring tape, but if you don't have one of those, you can use a string, a piece of string, and a ruler or a measuring tape. So here's what I'm talking about with that flexible measuring tape. A lot of times it's used when you're measuring for garments or for clothing. So if you have a parent who maybe has a sewing kit, they might have one in there. Otherwise, feel free to use a string and a measuring tape. Your items may be different than mine, but I'm going to start with the glass cup because it has the smallest distance around. And I'm measuring in centimeters. So diameter is across. And remember, the diameter goes from one edge of the circle to the other. So we don't want to cut it across close to the top. We want to go straight through the middle. And mine is exactly 6 centimeters in diameter. And then we're measuring around the outside of the cup. Make sure you measure in centimeters here as well. You wouldn't want to end up with the diameter in centimeters and then mix it up with the inches. So make sure you have it measured. Both of them are in centimeters. And mine's measuring at about 20.3 centimeters. Next on my list is a can of pineapple. So again, the diameter goes across the center of the circle, all the way from one side to the other. And this is sitting at about 8.4 centimeters. And then to go around the outside edge of the can, this is about 26.8. The next biggest item is a bucket, and it's not a big bucket, it's just like a little small bucket, kind of like what a kid would take to the beach. So measuring across from one edge of the circle to the other side, this is about 14.5. And then around the outside edge, about 46.9. And then my last item is that mixing bowl. And the bowl is kind of tapered in at the bottom, so I'm just making sure I'm measuring around the very top of the bowl. So from one side all the way across the circle, it's about 22.2 centimeters. And then we need to go around the outside of the top as well. It appears to be almost exactly 70 centimeters. Part B asks us to write the ratio of the distance around the circle to the diameter. So for the first one, that ratio would be 20.3 divided by 6. For the can of pineapple, it would be 26.8 divided by 8.4. For the small bucket, we would have 46.9 divided by 14.5. And for the mixing bowl, our ratio would be 70 divided by 22.2. Then in part C, it asks us to find the value of each ratio. So for the cup, if we divide 20.3 by 6, that will give us the value of the ratio. So we're going to divide the numerator by the denominator in all of these cases. And so that first one comes out to 3.38. For the pineapple, 26.8 divided by 8.4 is 3.19. And I'm just rounding to the hundredths place like it asks. For the bucket, we have 46.9 divided by 14.5, which is 3.23. And for the bowl, 70 divided by 22.2 is 3.15. So I'm filling this in with the information from our table. Oh, 14.5 and 46.9. Our last one was 22.2 and 70. And then it says show line. Now, if we look very closely, you can see that my points don't fall directly on the line, but they are very close. Do you think that the distance around a circle and the distance across, or the diameter, have a proportional relationship? Well, when we found the value of the ratio, our numbers were all pretty similar, but they weren't exact. And typically in a proportional relationship, we're looking for them to be the same. But this does seem to form a nearly straight line. Most of those points fall pretty close on that line, and it does go through 0, 0. So what might be the reason that this didn't come out perfectly identical for the value of those ratios? Well, keep in mind we're using a measuring tape or a string. I'm trying to hold that measuring tape or that string around the outside of your object or across the center of your object can be kind of difficult, one if you're by yourself or even just in general. And then to make sure that you measure it exactly, that can be difficult as well. Keep in mind we only used the tenths place in many of these cases. And so if we were to able to measure it to the hundredths place, we might have even been more precise. So there might be some human error involved in these values. And since our dots or our points fall pretty close along this line, it would make sense for that relationship to be proportional. If we zoom in on our graph, remember we talked about how that point 1K represents that constant of proportionality, and it looks like it's just barely above, this would be the number 3. So it might be somewhere around 3.1. Now it says use the relationship to determine the approximate circumference of the circle in problem 1. So if we measure across our circle using that ruler, and we multiply it by 3.1, that should give us a better approximation of the distance around the circle. In problem 1, that circle was about 12 centimeters across. So that distance around the outside, which has a fancy name, circumference, is about 3.1 times the diameter. And we just said that the diameter was about 12 centimeters. So 3.1 times 12. So our new approximation for the circumference is 37.2 centimeters. When we were working with like rectangles or squares or triangles, that distance around the outside of a shape we called the perimeter. In a circle, the perimeter of a circle has a fancy name called a circumference. And that constant of proportionality is about 3.1 times the diameter. For problems 5 through 7, find the approximate circumference of the circle. Use 3.1 as the constant number. Now we're going to get a little bit more precise than your book requires, and we're actually going to use the more popular approximation for this value of the ratio, which is 3.14. And you may have heard that number before, and you might know what it's called, but for now we're just going to use that approximation of the value of the ratio. So here, the circumference would be 3.14 times the diameter. Well, this is the radius. So if we want the diameter, we have to go all the way across. 5 goes halfway across, so the whole distance here is 5 and 5, which is 10. So in this case, the circumference, or that measurement around the outside of the circle, or the perimeter, would be 31.4, and this one was measured in inches. A circle has a diameter of 4.1 feet. So this one does give us the diameter. We're going to multiply by 4.1. Your warm-up use multiplication of decimals to kind of get you prepared for working with these values. And that comes out to 12.874. And remember, we're using feet in this case. So the distance around a circle with a diameter of 4.1 feet is about 12.874. This one has a diameter of 20.5 meters. So we're multiplying that value of the ratio by 20.5, and that is 64.37 meters around the outside of the circle. Consider a circle with a circumference of approximately 40.3 centimeters. What is the approximate diameter of a circle? Well, the way that we've been finding that is the circumference is equal to that value of the ratio multiplied by the diameter. In this case, it tells us the circumference, so that's going to go in the place of C. And we need to solve it for the diameter. So think about this as like an equation, something like this. 40 equals 3D. To solve it, we would divide both sides by 3. Well, in this problem, the diameter is multiplied by 3.14, so we want to divide by that on both sides. So 40.3 divided by 3.14 is about 12.83, and we're just going to round to the hundredths place. And that is measured in centimeters. We'll get to learn more about what the value of that ratio in a circle is in upcoming lessons. So you'll learn more about the name and a better way to represent that value of the ratio. Because it's not exactly 3.1 and it's not exactly 3.14. There's a specific value of that ratio, and we'll get to talk more about that in upcoming lessons.